All right, let's dive in. Today, we're tackling long context language models and more specifically, how to train them effectively. And we've got some fascinating research to unpack.
Yeah, this paper really goes deep. It challenges some assumptions in the field.
Okay, so just to set the stage, we're talking models that can process huge amounts of text. Imagine like feeding an entire textbook into a model and it actually understands it.
Exactly, but evaluating these long context models, trickier than it sounds.
Right, like perplexity, which works for short sequences, just doesn't cut it with these massive text lengths.
It's not just predicting the next word anymore, right? It's about understanding complex relationships across vast stretches of text, grasping those nuances of meaning.
And that's where this research gets really interesting, right? They say we need better benchmarks, more real-world focus to really see what these models can do. So they're using something called the Helmut benchmark.
Right. It tests things like retrieval augmented generation, where the model actually has to pull information from outside sources to answer questions.
So it's like the model's doing its own research. That's pretty wild. What else does this Helmut thing test?
Oh, a whole bunch of stuff. Re-ranking documents, in-context learning, like how we humans do it, even question answering based on like a whole book and summarizing dense legal documents, really puts these models through the ringer.
And this is where it gets even more interesting. They found that evaluating the models only after supervised fine-tuning, SFT, gave a much clearer picture of their long context capabilities.
Yeah, that was a key insight. They saw big improvements in things like RG and re-ranking after SFT, improvements they might have missed otherwise.
So just training on a massive data set isn't enough. You need to fine-tune them with instructions to really see what they can do.
Exactly. And SFT also lets researchers test things like question answering and summarization, which need instruction following and don't work well without it.
Okay, so got to be smart about how and when you evaluate. But now the nitty-gritty. How do we actually train these long context champs? What's the secret sauce?
It all starts with the data. This study found that a good mix of long and short form content is crucial. Actually, they found that code repositories, with their intricate structures and dependencies, were amazing for training long context models.
Code repositories. Interesting. But I guess code does require a very precise logical structure, like a good language model.
Exactly. But here's the catch. Too much long context data can actually backfire. It can hurt the model's ability to handle shorter texts. So finding the right balance is key. A blend of code, books, and high-quality short stuff.
That's a gourmet meal for your model, right? The right ingredients, the right proportions.
And speaking of pushing boundaries, they made a fascinating discovery about training sequence lengths. You'd think training on the longest possible sequences would be best, right? To match the model's intended context window.
Yeah, makes sense. Train for the marathon you're going to run.
Well, they found the opposite. Training on sequences even longer than those used in the evaluations actually led to better performance.
Wait, seriously, that's counterintuitive. Why would pushing the model beyond its intended context length actually help?
It seems that by stretching the model's limits, you make it develop more robust representations of language.
Okay, so data and sequence lengths. What about supervised fine-tuning? What did they learn there?
Another interesting finding. A lot of people thought you'd need equally long instruction datasets for fine-tuning, but they proved that wrong. They found that using standard short context instruction datasets was enough to get excellent long context performance.
Wow, so even though the models are trained on tons of text, they can still learn from short instructions.
Yep. Adding long synthetic data didn't help and sometimes even hurt. Quality over quantity, right?
Fascinating. So it's not about bombarding them with info, but giving clear, concise guidance. Now tell me about this model that brings all these insights together. ProLong, right?
Yes, ProLong. 8 billion parameters, trained using that special mix of code, books, and short context data, pushed to its limits with those ultra-long sequences, and then fine-tuned with those concise instructions.
And
Impressive, right?
don't hold back.
It is. ProLong sets a new standard. It beats even Llama 3.1 in most tasks, and get this, it does it using a fraction of the data. We're talking 5% of the data Llama 3.1 used for its long context training.
That's amazing. So ProLong is lean and mean, but how long are we talking? Exactly, give me the numbers.
Hold on to your hat. ProLong can handle up to 512,000 tokens. That's 250,000 words. Imagine that. Models understanding whole novels, scientific papers, legal documents, all at once.
Mind-blowing. But did they test it on unseen data? We want to make sure it's not just memorizing stuff it's already seen.
To really test ProLong, they went beyond Helmet and used another benchmark called NOCHA. NOCHA uses recent fiction books to test the model.
Clever. So like giving it a pop quiz on a book it's never read.
Exactly. And ProLong passed with flying colors, proving its long context skills on brand new material. This model isn't just memorizing, it's understanding.
This is seriously groundbreaking stuff. So many questions. But for now, let's let our listeners process this incredible research. We'll be back soon to dive even deeper into ProLong and what it all means for the future of AI.
Welcome back. Last time we were talking about ProLong, that model that can handle 250,000 words in one go.
Yeah, it's still blowing my mind. But we got to go beyond. It's impressive, right? Let's break down how it performs on those benchmarks.
Good point. So Helmet, remember that suite of tests? ProLong really shines there, especially in retrieval augmented generation, R.
Right, RAG. The model has to pull in outside info to answer questions, almost like doing research on the fly.
Exactly. ProLong consistently did better than other models on Helmet's RAG tasks. Really good at combining info from different sources and giving accurate answers.
So for question answering, complex research, ProLong has a real advantage. What other tasks was it good at?
Another one was re-ranking, taking a bunch of jumbled documents and putting them in order.
Right, so understanding the relationships between pieces of information, creating a structure.
Exactly. ProLong did really well with that on Helmet. Showing it understands how documents relate to each other could be a game changer for information retrieval.
In-context learning, ICL, is really interesting to me. It's like the model is learning by watching, right? Picking up new skills from just a few examples.
Then ProLong shows real potential there. On the ICL tasks, it was great at adapting and learning on the fly. Almost human-like.
So many possibilities. Models learning to compose music, write code in different languages.
The potential is huge. And of course, we can't forget summarization. That's what got us all excited about long context models in the first place.
Yeah, condensing tons of information into a digestible summary. That's super valuable. So how did ProLong do with that?
Well, the Helmet benchmark used really long legal documents. Tough task. You need a deep understanding to pull out the important points.
It's not just shortening. It's about capturing the essence.
Yeah.
Accurately and concisely.
Exactly. ProLong did well, generated good summaries, especially considering how Helmet evaluates them. Another language model actually scores them based on how faithful they are to the original.
So it's like an expert judge is assessing the work. Okay, so ProLong is multi-talented, good at RAG, re-ranking, ICL, and summarization. But all of that was at 128,000 tokens. What happens when you really push it, that 512,000 limit?
Now things get really interesting. Most models can't even handle that length, right? They focused on the question answering and summarization tasks from Helmet, but at lengths from 32,000 all the way up to 512,000.
Really putting it to the test. Did it break?
Not at all. The results were great. ProLong kept performing well, even at those lengths, and in some cases, it actually got better as the context got longer.
Hold on, better with more context. That's incredible. Like giving a detective more clues and they solve the case faster.
Yeah, it means ProLong doesn't hit a ceiling at 128,000. It can handle even more information. Huge possibilities for the future.
We're talking understanding entire books, research papers. All right, let's dive in. Today, we're tackling long context language models and more specifically, how to train them effectively. And we've got some fascinating research to unpack.
Yeah, this paper really goes deep, challenges some assumptions in the field.
Okay, so just to set the stage, we're talking models that can process huge amounts of text. Imagine like feeding an entire textbook into a model and it actually understands it.
Exactly, but evaluating these long context models. Oh, hey, I think our listeners got something to say.
Hey there, does this work propose the longer training for the small models it work?
That's a great question. It does touch on how even smaller models can benefit from longer training, yes.
Okay, let's unpack this. While it doesn't explicitly focus only on small models, the research shows that this technique of long context training is quite effective, even for the smaller models.
What's fascinating is the paper uses an 8 billion parameter model as their starting point, And they got amazing results, even with that smaller size.
So the key isn't just about having a huge model, but about how it's trained. And they're really highlighting the efficiency of this method with the ProLong model.
Exactly. And I think it's important to remember that this whole approach is about making the most out of the data. They really focus on data efficiency, and that benefits everyone, especially those with smaller models.
Here's where it gets really interesting. They say we need better benchmarks, more real-world focused, to really